Alright, hi everyone. This video has a bit of a different setting and I guess a feel to it because, it's a bit late right now and I don't usually record late during the day, but I just wanted to make a quick video about a few concepts related to coding, so learning coding, applying coding skills and stuff like that. Generally, I think this video would be aimed for people that have trouble approaching it, or people that have tried to start learning but don't necessarily understand how to kind of make the cognitive link between creating instructional logic and actually turning that into code. I might put my glasses on for this one because I usually do that for the coding related things as well. So one thing I've always tried to get across in videos teaching people how to understand or actually to write code in certain contexts. On the main channel, that would be generally with the intro to coding video, which is applicable to any language, and then also the Python crash course for Blender, which is very, Python and Blender specific. The thing that's similar between them is I tried to impart the importance of instructional logic, which basically means forget the syntax of any language and forget the mathematical requirements. So basically you don't have to be good at mental maths and you don't need to understand, complex algorithms and stuff like that. Just think in a very instructional way, like if you're following a recipe for making a certain meal. Instructional logic is where everything starts in code. It's where you basically describe your operations and your functions and what you want to happen. Everything starts with that idea and that basic fundamental logic. Once you have that idea, the difficult step is then understanding how to turn that into specific code. So following the very specific syntax of a specific language, and then all of the extra requirements which come along with the context that the language is used in. So there might be a different software environment, or it may require the use of certain modules which have their own rule sets and stuff like that. I think there are a certain number of new learners which encounter the misconception that to even understand the fundamental basic logic of how to describe functions in software requires that they also understand the highly complex syntax of a specific language, which just isn't true. So one piece of advice which I tried to give some other creator learners is, instead of sitting down and trying to code, one thing you should do is, away from the computer, on pen and paper, literally write out what you want to happen. So if we use the example of Blender, let's say that for every collection in the outliner, we want to look for collections which include the word potato, for example, and maybe delete them. So maybe it's like a cleanup script. So on paper, I would write something like, for every collection in the blend file, that would be my first line. Then underneath it, I would go, well, if the collection has potato in the name, and then the next line would be, delete this collection. So I'm literally writing out in plain English exactly what I want to happen. Okay, so that's the start. None of that requires any syntax or any understanding of a programming language. What that does require is a kind of understanding of where to stop an instruction, so where to make new lines, and that's something that you just generally pick up by experimenting. But there is a word for this, and this is called pseudocode. Now, pseudocode is a bit of a vague term because, well, if you know what programmers are like, they like to version everything and have very specific definitions for things and give, even ideas, different versions. Just forget all of that. Pseudocode is basically a simplified, more abstract, incomplete version of code. So when you're writing out your ideas for what you want the code to do, you would call that pseudocode. It can be as simple or as complex as you like. But then again, as I said, there's probably like a bunch of really professional and really stuck up programmers which are like, no, pseudocode requires that you define variables in a certain way and blah, 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 blah. Forget those guys. So once you have your basic plain English language recipe, what I would do then is I would take those handwritten lines and I would go into the environment where I'm writing the code. And in pretty much every language, there's a way to write comments, which are basically lines which are not regarded by the compiler. So lines which the computer ignores pretty much when it's turning your code into an actual usable thing. So I would take all of those plain English lines that I've written and put them inside of the code as comments. So we have our for every collection in the blend file. If the collection contains potato in the name, delete the collection. So now I've got my recipe there inside of the code. Well, now it's just a matter of finding out what the code should be for each of those lines. So here's the main psychological point about this. Instead of staring at a blank sheet of code and not knowing specifically what to write or specifically what I want to happen, so basically figuring out the logic at the same time as you're figuring out the syntax, forget that. Instead of doing that, we're figuring out the logic entirely beforehand. Then we're putting it right in front of us. And then step by step, one by one, we can figure out the syntax for each of those lines. Now that is a much more digestible and welcoming way to approach writing code. It's not a hack, it's not a cheat, it's just another way of writing code. And in fact, back when I was learning code, in the books that I was reading, they put a big emphasis on pseudocode. You know, basically visualizing and writing out what you want to happen before you actually write it. But I think that nowadays, and I guess I'm guilty of this as well, I don't see much of an emphasis about pseudocode in coding tutorials. I think part of that is because in online tutorials it doesn't seem necessary, because I think in a way it's considered wasted time. You know, if you're coming to a video to learn how to do a specific thing, do you really need to sit and talk about, you know, all the voodoo psychological aspects of kind of understanding your logic before you're writing into code? Obviously, I think it's very important. And like I said before, pseudocode can be transferred into any language you like. It's important to get the logic down and understand exactly what you want to happen in your own mind, on paper, whatever helps, before you start writing. Now, obviously, if you're an experienced programmer, you can just get writing right away. You know, it's easy to read it as you're writing it. You already understand the syntax, you know what's going on and whatever, but like there's no requirement for that, and there never will be. And yes, this is, by the way, how I write a lot of my code, not all of it. You know, there's a lot of the more boring kind of, I'm tempted to say, admin side of programming, which doesn't require, you know, pre-writing all of this stuff. But when I need to create a specific algorithm or a certain function that just hasn't been done and like doesn't exist, if I'm being really honest, I tend to write it while I'm on the toilet, like on a notepad, because for some reason that's proven to be like the most effective place to come up with like instructional logic bytes. It must have something to do with focus. But yeah, I'll put everything down in comments and then I'll work on them one by one. And in some situations, I'll look at some of those lines and think, okay, well, I've already done this task in another project or another code file. So I'll go back and look through some of my older work, pull out the relevant line, and then copy and paste that into the new one. If there are any like extra things that need to be changed, like variable names or some like very specific changes for this task, then I'll do that. But you know, I can go back and recycle lines when I think they're gonna fit. Working on a line by line basis like this is much less daunting, especially for newer learners and people that I think are coming over from different types of skill sets that aren't necessarily thinking like a programmer in their day-to-day life. So I'm doing this all in my head, by the way, because I didn't really prepare like the main example until I had my shower like half an hour ago. So I'm going to use the example of Python in Blender. That first line, as we said, is for every collection in the blend file. Okay, how would you write that in Python? Well, Python has a nice way of expressing things, and again, in quite plain English terms. So I might do something like for C in bpy.data.collections with a colon at the end. So what this line means is for every collection in bpy.data.collections, which is where the collections are stored in the Blender API. It's basically just an address, like a web address. We're used to seeing forward slashes in web addresses, but dots are basically our forward slashes in code. C in this case is just a variable that represents every individual collection. So anything we write under this now to modify C in some way is going to happen to every collection in the blend file. Now this line is something that you might have to learn. It might be something that you've picked up in a tutorial. It may be something that you looked for help for online. But now you know what to write and it's there. And if you like, you can get rid of your original comment, or you can leave it in if you want to use it to help you to understand what's going on in your code. Because that's another thing as well. If you want to, your code doesn't just have to be code. You can just leave comments in, which are the plain English equivalent of what's going on, so you can navigate your way through the code more easily without having to read the code and then try and understand, okay, yeah, that's where this piece of logic is going on. Okay, so what was the next line? It was, if the name of the collection contains potato. Alright, well I'm adding this bit after the fact because I wanted to add an extra bit of information which I didn't talk about in the original recording. So for this line here, if the collection contains potato in the name, there are a few different ways you can like assess what content is inside of a name. So the name in this case would be c.name. And c.name is a string, which is like another word for basically just a collection of characters. So a string of characters. Now with strings, there are nice convenient functions where you can do things like dot starts with. So we could check if it starts with potato. I would need to put an if at the beginning here. So if the name of the collection starts with potato, we could also do ends with. So if the collection name ends with potato. So that's quite self-explanatory. It's literally as it describes. But to check if there's a word inside of another string, one really simple thing you can do in Python is literally this. So if potato in c.name. So literally if potato can be found inside of the name, then carry on. So for every collection in the Blender file, for C in the collection list, if the collection contains potato, if potato is in the name. So now we have successfully converted our second plain English line into a line of code. Well, look at that. We're already 2/3 of the way through our program. We didn't have to sit down and write it from scratch. We knew exactly what we wanted to happen. The only thing we needed to figure out was not the specifics of what needed to happen, but just the syntax to describe it for that language. The last line here is to delete any collection which contains potato, and to do that we can go back to where the collections are stored, so bpy.data.collections, and then this storage area has its own function called .remove, and then in here inside of the brackets we can pass C, which is our reference to the individual collection. Now we know it's only going to happen if this collection contains potato. Because of the scope, you can see we're going in tabs every time we're opening a condition. Okay, so there you go. You've now taken your plain English description of what you want to happen and you've turned it into code. So again, the main point of this technique is just showing you that you don't have to sit down on a blank screen, figure out the logic at the same time as figuring out the syntax. I think those two things combined are one of the main off-putting points for people that don't have experience with programming and are daunted by the mental gymnastics required to make it work. I think most people are capable of figuring out one or the other of those things at a time, as in figuring out what you want to happen and then figuring out how to describe it in code. But both of them at the same time can be off-putting and daunting. So if you are new to the coding space and you're having trouble learning, I just think that's one thing to keep in mind. Practice describing things, actions in an instructional way in your real life. Even if you're not writing code, just get used to describing what you want to happen in stages and steps. Another thing I want to get across in this little video is not to learn things in isolation. Now what I mean by that is having certain technical or artistic skills in a certain department should, in theory, make it easier to pick up other somewhat related skills. If you've understood the theory of code and programming languages and you learn one language, in theory you should be able to pick up another language pretty quickly, especially when compared to not having known one at all. The same thing generally applies to artistic skills, but again it depends kind of, I think, how you learn those skills in the first place, how closed in you are in a perspective box, if you want to think about it that way. The context is also quite important. In theory, if you develop generalized artistic skills when using one piece of software, once you finally understand the interface and the features of another piece of software, those skills should transfer. But there are a lot of caveats to specific skills and contexts, but basically the point I'm making here is that if you already have some skills in any department, then you can use these as a bouncing platform to learn new ones. And you might think, okay, well, I'm only an artist. How do artistic skills transfer into code? Well, again, with the context of Blender, artistic skills quite obviously transfer into code because you can manipulate the artwork you make using Python. So instead of going to a dedicated website where you learn Python in complete isolation, just learning about the syntax and manipulating numbers and words in a very efficient way to show you what the different features of the language do, I think it's much better to learn it in the context of other projects, other artistic projects. So instead of learning how to manipulate text in a very plain way on a website, maybe you can learn to manipulate a 3D text object in a Blender scene and use that to create something artistic. Another example might be, instead of learning how to construct lists in isolation by just making a list of numbers, maybe we can make lists of light objects in Blender and then create a script to randomize their properties like color. Now that's something you can aim for yourself. You can think, oh yeah, maybe there are some elements of my artwork that I want to try and manipulate with Python, and I can look those up with Google and other resources, see if there are any tutorials available to try and make that work. Now I think people coming from the artistic side of the skill set probably learn a lot from tutorial content. So the question here would be, okay, well that sounds great in theory, but is there actually much content available to help with that? Like, we would like demonstrations showing us how to manipulate those specific parts of like Blend files, so we can learn the syntax and learn the context and all of that. And yeah, I don't think there is much content for it. And, maybe I'm partly at fault for that. It's not just about teaching Python in Blender, it's about learning how to manipulate things. So Sibrin from the development team has done a kind of course like that, scripting for artists. Sibrin comes from a more computer science background. I've heard good things about the course. I also heard that some people got lost kind of about halfway through. As with any tutorial content, people resonate with different people's teaching styles in different ways. This is why it's nice having like a wider variety of educators. The more the merrier, because ultimately the more teachers there are, the more of a chance that someone is going to find someone that they attach to as a teacher and will understand easily. When I do my content, I tend to try and take the analogy or metaphor approach, which is where even though we're trying to do things within an artistic context, so in my Python crash course for Blender, we tried making like a mesh which had a randomized displacement shape on it, and we also manipulated the materials to show how you can make it emissive. Also, while teaching those concepts, I tried to attach it to analogies to try and make it more approachable and understanding by relating it to things which people may see in their day-to-day life. So there was a part later on in that video talking about the construction of add-ons, which requires a lot of kind of weird, daunting, boring extra code to make it readable by Blender. I would use an analogy like, okay, well, imagine you've ordered a delivery off of Amazon. That delivery comes with a bunch of necessary packaging and labeling. You don't really care about the labeling, but it's there because it's important to make sure that Amazon knows where to put the package, where to send it. The same thing applies in Blender, which is where when you're writing an add-on which is going to be installed onto other people's versions of Blender, there's a necessary amount of labeling and packaging so Blender knows where to put your functions. So an analogy like that helps people understand, okay, this doesn't look meaningless anymore. I might not be able to read it, but I know generally what's going on. Now, going back to the whole, well, we want to manipulate our artwork in Python in Blender, but we don't know how to access different parts of the data. Again, in my crash course, that's something I tried to explain because I tried to go over everything. How to make modifiers, how to modify modifiers, how to make materials, how to modify them, and everything like that, step by step. You'll find when going through demonstrations like that there are very definite similarities in the ways to access data. This is something that's true with pretty much all programming languages. Once you identify how to create, access and modify different types of data, you'll be able to see patterns and make good educated guesses on how to modify other types of data, because the rules generally stay the same, just like with most spoken languages. Like, I've never told someone to walk down the road, speak to an elephant and encourage it to pick up a bucket. I have never thought about requiring these certain words or the certain structure of the words to tell someone how to do that. But because I understand the rules and the patterns of the English language, I'm confident that I would be able to explain how to do it. The same thing applies with code, so with Python in this case. If collections are stored in bpy.data.collections and materials are stored in bpy.data.materials, then where are textures stored? Where are objects stored? We can make an educated guess, bpy.data.objects, bpy.data.textures. And that's true. Something that helps with this, and is again explained in that crash course, is that in the interactive Python console, there's an autocomplete feature where you can see all of the possible child data points and functions which are connected to a certain path. So you'll be able to go to bpy.data and then do dot and then see all the possible things which could follow. So that's a way to discover where to access data and where to manipulate it. And there's also the helpful thing, which is the Python tooltips, which is where if there's a value in Blender you want to modify, if you've got that enabled, you can hover over it and it will tell you the Python path right there. And if that wasn't enough to simplify the entire process of figuring out how to modify things, the info window in Blender, whenever you perform a task, it will write out the exact Python line right there for what you've done. So strictly speaking, it wouldn't be very pretty and it wouldn't be very clean, but if you performed all of the actions you wanted to automate, you could go back to that window, take a look at what happened and pretty much just copy it down, and that's your script. There are caveats to that because it's not exactly clean and things might not work as expected. Now, of course, I'm giving the context of Blender here, but the same thing applies to other programming languages and other contexts, so C# and Unity, for example. In Unity, C# and pretty much any language in there works on a component stack system. A component stack system is where things are calculated in a linear fashion, and the perfect example of this is the modifier stack in Blender. There is one operation, then there's another one, and so on. All of these are manipulating a collection of data, so in Blender, it's a mesh. In a game engine like Unity, it might be more complex than that, because a specific game object can have many different types of data, and components can interact with other components. This is where the complexity and abstraction of code comes in, because the components can take inputs which are other components and then modify the values in those, and it gets very abstract and strange. It can be as complex as you want it to be. But here's the main point I want to get across. Even though it's a different language, there are still similarities and patterns which can be identified. Let's say in C# and Unity, use a getComponent function to grab a very specific component, so basically a script that's on another object. So let's say you use it to grab a script which makes a ball bounce up and down. and maybe the script is called bouncer. So you do the get component, bouncer, and you go for it that way. You have your open and close brackets, you have your dot to access the data which follows. We understand, as I said, the dot is basically like our URL forward slashes, but for code. So much like how the dot in Python represents moving down into child data, the same thing applies to C# and most other languages. So again, patterns can be identified. But once you know that's the way to access that specific component, you know, oh, okay, I can access any component now. Not just the bouncer script, but let's say I have a different script for a different object which provides like space flight control, which manages inputs coming from a controller and modifies physics values on a rigid body component. Okay, well, that space controller might look for the rigid body component on an object, but I want to modify the space controller script from my script over here, so I'm going to use the get component to get that script. So you understand that you've used get component before, you can use it again for any other script you like. You can also use it on different layers as well, so you can keep using that to access content. Once you know how it works functionally in one place, you'll know how to use it everywhere else. So those are the things I just wanted to get across for this video. So the first thing, going back, is a different way of thinking about approaching writing code, which is writing your stuff out in a pseudocode-like way. We are basically writing an instructional recipe in complete plain English. And again, I would recommend kind of just getting used to writing instructions, even without the context of code, maybe just for regular everyday activities. Following on from that, we were talking about not learning things in isolation, because you can use the benefit of your pre-existing skills to help you learn new ones, even if they're not directly related. So artistic skills can help you learn technical skills. Technical skills could help you learn artistic skills if you're using them within a similar context, you know, if the context allows for it. So again, for example, Blender allows for this because it allows us to modify our artwork with Python. Similar thing with Unity and C# as well. And again, I guess the last point was about identifying patterns and knowing that if you learn how to access data in one situation, because this is basically a language and the rules are consistent, you can learn how to access different types of data in other situations using the same technique. So hopefully, I guess the aim of this video is to make things seem a bit less daunting and to help you understand that there is no single approach to kind of getting your head around these things. It doesn't necessarily require you sitting there and kind of like hardcore just typing as you go, like, you know, a Sims character. I don't know if everyone watching's played the game, but you can tell them to work at a computer and they just sit down and do it. It's not necessarily like that. You know, you can take the full process of the work away with you, prepare elsewhere, bring it back, break it down sequentially, and see if that helps. So thank you for listening to this video. Hope you're doing well, stay safe, and I will see you next time.